Hello everybody, it is Caleb, and today I wanted to show a different way of creating matrix cell fixtures in Unreal Engine that is much faster than the methods I've shown in the past. It doesn't allow quite as much level of granular detail yet. I'm hoping to get there and find a way to bridge this gap. But for now, this is a very quick way of getting multi-instance matrix fixtures up in Unreal Engine. I do want to show where we're going with this tutorial. By the end of this, we should be able to apply numerous beams, custom beams with a custom material to our multi-cell fixture. And then we can also create another fixture just by creating a DMX patch essentially. So I do want to give a thank you to my Patreon supporters for helping me both financially and motivationally in creating these fixtures in a way that the rest of the industry agrees with, like using GDTF imports and making these respond to the MVR workflow and getting closer and closer to Unreal's actual vision of easy to make DMX controllable fixtures, whereas on fixtures like this, like the Rocks Blinder, they look decent and I can customize very granular detail, but it doesn't work as well with Epic Games' system of DMX. And so we are working to reverse engineer that. So I want to thank everybody. Let's get into this video. So let's get started. The first thing you're going to do is under your engine plugin content, you're going to want to scroll down to DMX fixtures content and light fixtures, and then find this moving matrix, and then copy that. And if you need to take this static matrix, I'm sure that works very similar. In fact, I'm going to copy that. I've already copied this one. I'm going to copy this to try this out during this video. So you get to see me try something live in a video. That doesn't happen often because I'm going on vacation soon. And I do want to get this information out to you. There we go, static matrix. So I'm going to use the moving matrix first because I'm creating a GLP X4 bar. So once you have this in, I like to then copy this to where I want to be. So I have this folder called single pixel v3. I'm going to copy that into here, and then we can start building off this fixture. So I'm going to call this GLP X4 v3. Even though it's an X4 bar, I don't have the X4 in yet, so I'll rename that later. And then drag it into your world. And what you're going to need to do is create a DMX library for it. And so I have, for mine, it's in shared assets. However you get to your DMX library, there's a number of ways to get there. You want to create a fixture profile for your multi-instance fixture. And so for the X4 bar, it's this tilt in 16-bit, and then shutter, dimmer. I don't know why I have that, actually, to be honest. Or reset, because I'm never going to reset a virtual fixture. But what it's going to look at to build your mesh is this fixture matrix here, 20 by 1. And then you add in your cell attributes. We're going to save this, and then make sure you go to patch and patch at least one. I've got a whole bunch patched right now. And then that is how it's going to build this head. So you're going to go to DMX patch tool with your dragged in new light selected. And we're going to hit address incremental on this X4 library, the first fixture. What that does is patch this to this patch, and then you scroll down or up to generate preview mesh. And there you have your X4 bar. Now we can dial this in quite a bit. So let's go to our edit the blueprint, and you'll see these matrix width and height parameters. And so these are consistent for the entire GLP X4 V3 bar. So we're going to want to change the width of it by a bit, and then change the height and the depth to look sort of like an X4 bar or whatever fixture you're trying to make. After that, you can compile and save. And then your yoke, I'm gonna try to do this. Last night I did it with importing in my old body fixtures. I'm gonna try to do this without importing anything. So let's see if we can just adjust the scale of our yoke. Well, kinda. It doesn't work very well. I wish we could adjust the width of it procedurally. But what you might need to do is go into Blender, and for whatever shape you're making, in fact, I can do that now. The process in Blender, if you want to make a yoke with different width, is you could start with this cube, and then I'm gonna hit S. Let's scale it on the X. SX. Actually, that's not quite a good way to do it, so I'm gonna undo that. If you go to this dimensions, you can make it a bit more dialed in. And then if you ever do bevels, then they're not gonna be warped a different shape. So I'm gonna say that this fixture is 1.5 meters across, maybe 0.2 meters thick. And remember, we're building the base right here. So I can say 0.1. And then I'm gonna add, not on there. I'm gonna add another like 0.2 meters. And let's just add 0.1. And then hit tab for edit. And then Control R. And what Control R does is a loop cut. So you can add a cut here, here, or here. We're going to add it here. We're actually going to add two so we can make it uniform. Click once, and then hit SX again to scale these two things out. We're going to do that. Push it to right about there. And then grab these two faces by holding Shift, and then hit E for extrude and bring them up. And then we can bevel that edge and make it look a little bit better by going to Edge Select here. Select all four edges. Relocate our bevel option right here under Edit Mode. And then raise this segments to like 3. And then go ahead and round that off by a little bit. And then if you want to bring this further down, you could hit SX for scale on the x-axis. And then I would hit, or sorry, SZ is what I press, not SX. And then I'm going to hit GZ and then bring it down a little bit. This can serve as my more primitive base. And so I'm going to export this under an FBX, go to my Blender export and call it X4 base basic. We don't need to create the head because it's going to create the head. Let's minimize out of this. And you won't always need to create a head. The X4 is kind of a unique fixture. So I'm going to go to my documents, Blender exports, find wherever I put it. X4 base basic, and then we're going to drag and drop this in so we can import it. It's going to say there's no smoothing groups. Smoothing groups take up to more faces. We don't want that. I mean, we can. If you wanted to smooth it, just hit shade smooth, and it looks ugly. The reason for that is because we have a bunch of hard edges here. So if you add more loop cuts and hit Control R, bring it down. Basically, you want to get 2 loop cuts right next to each other. That's just if you want it to look a little bit prettier. And then, yeah, you need to work some mesh magic around here. I'm not going to do that, though, because I don't really recommend having that many vertices on such a basic fixture like this. Once we have our fixture imported in, or our static mesh, you're probably going to want to go to the actual static mesh and assign in a material here. And there is this nice looking plastic that the game ships with. It's not even this generic plastic one, it's generic plastic black. That usually looks pretty good for most things that I do in here. Save that static mesh, and then under your fixture, you can go in here to the static mesh yoke and just change what static mesh this points to. So drag in your basic, and now you have an actual base. So we made this a little big, it seems. So you can scale this down, but we could also scale up our mesh. So I feel like the X4 bar does get to around 1 meter in length. And then we might have to, let's go into our viewport. Might have to raise this up a bit. And then the base, we can actually get rid of this static mesh. And just in case any static mesh does appear here again, we can change that scale to 0, 0, 0. Save, and then go to self, and here you can find these width, height again. So here you can scale that up to whatever size you feel fit. And then if you want to position your head, you just take this head option, kind of drag it around to where you need. Once you do that, we should be able to drag in more of these. And upon patching them, if we patch it to, say, the next X4, and then hit generate preview mesh, it should just come up. So I'm going to try to control these two now through the Granime 3. And these will work in editor. So I have to do some network magic and make sure that I'm connected to my... I've been using a wireless router to send ArtNet across at home, even though it's not quite the preferred way of sending ArtNet. It allows, it's a hotspot router, so it allows me to send ArtNet data across while sharing internet. And then the IP addresses that it sends out are in the 10 range. So I have my laptop. You won't really get to see the Granime but I have my laptop connected to that router as well. So let me get some DMX flowing. Well, let me see if it's flowing now. It is. And so if I hit I hit blackout on this, oh, nothing yet. I think I might need to restart my Grand MA. Okay, it seems I'm connected now. And so if I flash my Grandmaster, I can see that I have DMX connection. Now I already have multiple X4 bars patched, I think. Yeah, I've got 8 patched right now. 1 to 1 and 1 to address 89. So I can sort of see that if I go to my address 89 here, it's 128, and back here it starts at 128 as well. So I do have them connected, so I can go 501 plus 502. And one thing I noticed that's not quite right with this when I do it is if I were to say 501 plus 502 at 0, it does not really track across. Whereas if I grab the X, well, I have highlight on right now, but if I were to do that, let's clear out again, 501 plus 502 at 0, nothing happens. If I were to grab the X4 cells, and then say X4 cells at 0, now it listens. And now I can hit highlight, and I have basically all the same control as I did before. In fact, I can even run my small little Q stack I created. And it will run the exact same effects. Now, one thing it doesn't have is zoom. I might be able to remedy that though by just adding a zoom component in here. Compile and save. Let's see what that does. If I go to 501 and 502 and I bring in my zoom, it seems to not be taking effect. Oh, highlights on again. But it seems like nothing's happening there. I'm bringing in my zoom and pulling it out. But that's how it's done. Let's see if we can make a Nexus or a yeah, let's try the Nexus 4x4 panel. Let me patch that in here. All right, I've got a Nexus panel patched at Universe 3. So I'm going to save and exit, and we should be able to see it come up here. 601 at full. There's our Nexus panel. That is a 4x4, not to be confused with the QPix that I improperly named Nexus for the longest time, because Nexus doesn't make a 5x5 panel. Let's try this static head and see where we get with that. Static matrix. And then under X4 library, we need to make, well, let's do some math real quick. This was a 48 channel option, I believe. Well, I guess we can look in our DMX activity monitor. Yeah, 48 channel. 4, 8, 12, 16. So 16 times 3 is 48. So it must be just a bunch of RGB channels. So this is going to be pretty easy to make. Let's make a new folder. Call it Nexus 4x4. Go in here. And then we'll copy our static matrix to it. And then this one's going to be done without any added meshes. So I believe we already dragged something in. Let's call this BP Nexus 4x4. We can drag that in. And what this doesn't do is get the strobe tables written. I'm currently working on a script to parse all that information from a GDTF file so that we can easily create these strobe tables, which I'll show you in a second. Nexus 4x4, we're going to patch that under, I think I forgot to make my profile. I'm currently working in the X4 library, but that's okay for now. You can work in whatever library you want. So we're going to add mode. You can call this 48 channel fixture matrix enabled, and all we need to do is add 3 values here: red, green, and blue. And then patch one in to universe 3, which looks to be filled with stuff. So let's delete those. And then we will add a fixture, Nexus 4x4. Under X cells, 4 and then 4. Now note that on my last fixture I created with the QPix, it was 5x5, but I just did 25 X cells. As I work closer towards this method of getting customizability and seamless integration with Unreal Engine's actual DMX workflow, I am going to need to adjust that method. So X cells 25 for a 5x5 fixture won't really fly anymore. So I will need to do some math there. Oh cool, it already updated our patch. So now we can see in fixture types we have a cell configuration of 4x4. It is patched, so we can go back to our main, hit patch tool, and then find our Nexus 4x4 address incremental. See that it's received the patch, and then generate a preview mesh. And there we go. If we black out to refresh our DMX values, that's where we get. Now I did try to add a beam to this. I have no current way to find how it's talking about the per pixel value. And so all I did was, well, let's finish up the Nexus panel first. But these are kind of what you see is what you get. There's not a lot of customizability in here. So I could take my Nexus 4x4 panel, go to fixture, I have a lot of fixtures in here, so it takes a minute to find. Okay, I grab my 16 cells and I can say at 0 and then it responds and then hit next. So that all tracks through. And then if I were to give this a lovely little effect of, say, blue to white, and then change my phase, now we could get some cool effects. So that is what I call the quick and dirty way of creating matrix fixtures in Unreal. It's certainly a lot faster than building your own meshes and materials and doing everything that way, but you don't get quite the same level of customizability. Now let me show you what I was talking about real quick. And this is the most in detail I'll go. If you wanted to add your own stuff to it, you can, but I can't find a way to access the per cell values unless I were to do, say, get all matrix cells. But the problem with doing that is it doesn't tie into the strobe component if I have it. So I can go under the head and say add a static mesh. That static mesh would point to, say, this X4 beam. Can't do that because that's a material, not a mesh. Static mesh beam, which is copied from engine content. So we can drag that to this static mesh and then full screen this a bit. And then the material of this would get our shared X4 beam master material. And then position it in the viewport. And now you'll find that if I flash my Grandmaster, it doesn't respond. The only way I have found to make it respond, and this would work with the color component, is you go to event graph here, and after on fixture patch received, we can see that tick. After this, you would then update your static mesh and say set vector parameter value on materials. You can get your material name by following this material here, which for whatever reason isn't coming up. And then we could see that our parameter name to control is x4 underscore color. And it's going to be, I think yours would be x4, or yours would be just like DMX color if you've copied directly from the engine content. And then one easy way I found to control that, and you would probably have to have your point light enabled, is you just, or your spotlight enabled, is you just rip from the spotlight component and say get color and get your light color. Right click to split that pin, right click to split these pins, and just connect your RGB to XYZ. And then set your parameter name to be X4 color or whatever matches in there, and then wire across. And then now we have a beam. And so maybe I'm going a little bit further than I intended with this tutorial here, but lo and behold, I got some sleep and things kind of sorted themselves out. So if we take this static mesh, rotate it 90 degrees, make sure we have our first cell. All right, so there's our first cell, and our beam is on that position. Let's try something quick and dirty real quick, even though we're getting prettier and prettier. We should theoretically be able to copy this across. And I'm only going to do 5 for this sample because I don't know if this method will work. But then we should be able to say on the construction script, and you'll recognize this function, create beam array. So we're going to drag out from here, promote to a variable, disconnect it so it doesn't think, change that variable type up here from single to array. And you can just exit out of that midway. It doesn't have to fully think about it. And then get that variable, say clear, and then get this variable again and say add. And note that we only have 5 beams. So I'm only going to do 5 adds here, but this should work if we have 20, if we can make 5 work. Connect all these up, and then let's add the items to our beam array. So static mesh 1, or 0, 1, 2, 3, and 4. Now we have a beam array with 5 elements stored inside. And if we go to event graph, we might be able to say with our DMX component, and then we say get fixture patch, and then we say get all matrix cells, maybe from here we can say get what we want is this normalized matrix cell values. What happens if we individualize these for each loop? And then can we split this pin? Yes, we can. So then we can get our coordinate. So this gets all of the cells in our matrix. This iterates over all of those cells. And that what we just saw is the array element. Each array element contains these 3 things, which can probably be split down further. But all we need is the cell coordinate, Then we can get our normalized matrix cell values, and then from here we get to somewhere recognizable. So we hit find. Red, green, and blue. And then we have an array index here. So in our static mesh array, we already have the index. We need to say get a copy. And then we pass that array index in. Now we have our each static mesh component. So now we need to say set vector parameter value on materials. That parameter name is x4_color. And then the parameter value, we could just wire all three of these in directly. Let's see if this works. I'm excited to test this. We need to pass our fixture patch in here as well. Okay. Now if we go to main, something's not making it across. There, it seems like it's working. All 5 are working. Oh, there we go. And there we are. I can't believe that worked. And so now we've just added, sort of customized this existing blueprint. Now the hard part is going to be, let's go ahead and finish this up. Some reason I've been having trouble with Pixel 1. In previous examples, it was seeming to not come up. Here it's seeming to not pass the parameter. Where's my 19? So yeah, my 19 is all the way over here without a cell. Can I just shift everything down then? There we go. Cool. So now I have this. And then we can go in here and lower our zoom value to something more like 10 degrees, make it a little more narrow. And then we would need to go to our blueprint in our construction script. create 4 more of these. If we go to our main, refresh some values, and now let's rerun our demo. Yeah, everything seems to work. Cool. Can I say how honestly excited I am about that? Because as I progress in these building of Unreal fixtures, see, now my pixels are off a bit. So there's some weirdness, but I've been finding ways to inch towards their practical application. And look how many frames per second I'm getting. 120 frames a second, and that's with OBS recording. So that's all I have. I hope y'all gained some value out of this. And if you want to support me in my Unreal DMX journey, which I seem to be infatuated with, go ahead and give me any subscription on Patreon, even just as a free member. Your involvement in there really helps me kind of know where the community wants to go, and just any feedback you have points me in the right direction on where the industry wants to go. Thank you everybody for watching. This will be my last video for the year before the new year turns, and once it's 2025, I hope to make a lot more content. Thank y'all for watching. Take care. Happy New Year's, and hope to see some of you around sometime. Maybe at LDI. I like to go to LDI from now on. So thank you everybody. Take care.